major utility upgrade scope of work. The city of Winston-Salem's existing water and sewer system needed to be improved, and there was a major water main upgrade along First Street right through the heart of downtown, from Peters Creek Parkway on the west side all the way to Church Street on the east. This work was completed in 2 block segments, and we coordinated for road closure and detours with both NCDOT and the city of Winston-Salem to accomplish this work. Intersection improvements throughout the downtown area were needed to be in place before the shutdown started. Utility relocation and upgrades were a big deal on the project. Most utilities had been in place for decades, and sometimes records were very scarce. It took a lot of coordination between the department and the city and utility owners to sort out what facilities were active and which ones were abandoned. As can be expected, dealing with old infrastructure led to some challenges, but luckily we had a great team in place and a lot of help from NCDOT to get through obstacles so the shutdown could occur as quickly as possible. Once the Peters Creek Parkway was constructed, the closure of I-40 Business began the fall of 2018. This allowed construction crews to start demolition of the existing roadway and bridges and begin reconstruction. The team focused on construction on the east end of the project. The eastern ramps were open to traffic in the fall of 2019. This allowed the highway traffic to access the downtown area from both the western side and now the eastern side of the project. Maintaining north and south access across the corridor throughout construction was a priority. The demolition of the existing bridges crossing the highway and the reconstruction of new bridges had to be phased in a particular way since there were several streets which were one-way traffic only. We coordinated these closures and detours with both the city and NCDOT to help optimize our construction schedule. The old highway, it was closed to traffic on November 17, 2018, and demolition started. This was, again, the first time NCDOT allowed complete closure of such a major highway for reconstruction. Once the shutdown began, it was essentially all hands on deck. Construction occurred concurrently, in multiple areas throughout the project location. Let's see, we have a couple of aerial photos. These aerials show progress between September 2018, prior to the closure of the highway, and December of 18. So that's only 3 short months, just after the shutdown began. The photo here shows all the work at Peters Creek Parkway area had to be complete before the shutdown began. This is the center area of the project. As you can see, there were a few of the existing bridges had to remain in place, which provided that north-south connectivity into the downtown area. And this photo is of the center to eastern section of the project. And there were some pretty significant changes to the roadway profile in this area. So these aerial photos are from May 2019, which is about 6 months from the last set of aerials that we just saw. You can see here the Broad Street Bridge is now complete and open to traffic, and the existing Green Street Bridge has been removed. Here in the center section of the project, we see Marshall Street remains open to traffic while the Cherry Street Bridge is being reconstructed. At the eastern limits of the project, the new Main Street Bridge and Church Street bridges are complete and open to traffic. Again, this is just 6 months after the closure began. Main Street and Church Street were reconstructed, open to traffic, which allowed, access into the downtown area. And this was followed by Liberty Street just 2 months later. To increase the clearances under the bridges while reducing impacts to the surrounding downtown areas, we had to lower the roadway profile and construct retaining walls. We had just about every type of retaining wall you can imagine on the project, from MSE to soil nail, cast in place concrete, and we even had some hybrid combination walls. This photo is an example of where we needed to avoid right-of-way impacts to historic boundaries. So you can see we used soil nail retaining wall transitions to MSE retaining walls at the bridge abutments. This photo shows one of the larger fill areas on the project and utilized a combination of MSE retaining wall and soil nail retaining walls to support the main line. The removal of existing bridge abutments can require large excavations. So we needed to consider these bridge abutments being removed when we evaluated the retaining wall types to go back in place. And, throughout design and construction, it required close coordination with utility design and utility relocation for both overhead and underground utilities. Detailing the retaining walls around roadway drainage structures could be tricky, and it took a lot of coordination from the team to accomplish that. There were, some instances during construction where the location of roadway drainage needed to be shifted, and we needed to make sure that any adjustments got carried through to the other disciplines. In tight conditions on a project similar to this, it's important to consider placement and the details of overhead sign structures also. So be sure to coordinate those details early in the process. So this project was a bit different than some of our typical NCDOT projects because the city of Winston-Salem was very involved throughout the project. They're essentially another owner because the project affected the city so greatly. We had specific committees where the design build team met with NCDOT and the city, and we would discuss important elements of the project. We discussed aesthetics, a lot of talk about the multi-use path, signals, for both NCDOT and the city, and of course, the water and wastewater utilities. Part of the aesthetic package, the new bridges included aesthetic elements that you can see here in the photo. You can see the decorative precast arch facades on the bridges. You can also see concrete pedestals on the bridges for future bridge lighting. And then the exterior face of the girders were painted to provide shadow effects to help the arches stand out. In this photo, you can see a little more detail of how the precast arch facades were attached to the structures. The precast segments are attached to the bridge deck with anchors and then supported by lateral bracing. Again, because aesthetics were such an important part of the project for the city and the community as a whole, a part of the aesthetic enhancement was to use brick facing on the retaining walls. You can see examples of finished product here with the brick facing on the retaining walls, along with the vertical concrete separations. There was ornamental fencing, which was specified along much of the corridor. And there was also textured noise walls, and you can sort of see that in the background of the photo. A lightweight noise wall was attached to the existing bridge over Crafton Street, located on the western limits of the project. The design build team coordinated the panel texture and color with the city and the DOT. And a transparent noise barrier was required along the Peters Creek Parkway Bridge. This interchange is a gateway into the downtown area from the west. So a transparent noise barrier was used to avoid obstructing the view of the downtown skyline as the motorist approached the downtown area. So the Strollway Pedestrian Bridge is one of the two signature structures on the project. It's located near the center of the project, and the city of Winston-Salem wanted to have a bridge that provided a unique park-like experience for its users. In the corner is a construction photo from November of 2019, and it's got a very similar view as the rendering. So there are built-in planters along both sides of the brick pathway. There's decorative lighting along the fence and in the bridge deck along the path. And the pedestrian fencing is tilted out away from the pathway to give an open feel. And the team worked very closely with the city to help determine the height of the planter walls and the angle of the pedestrian fencing tilting outward, as well as the material to use for the pathway. The city chose to have brick pavers along the pathway, which coordinated with other pavers, throughout the city. So our design, it also included landscaping for the planters and irrigation and drainage plans. The team worked with both the department and the city to develop a tiered gabion basket system at the bridge abutments. And these were added for aesthetic interest. So here are just a couple of photos of the finished bridge. You can see that the exterior concrete girder was painted dark to provide that shadow effect. And a solid pier wall for the interior vent was an aesthetic requirement by the city. In this photo, you can see the pedestrian lighting from above, as well as the lighting in the bridge deck itself, and you can see the finished landscaping. So now the Green Street Bridge. The Green Street Pedestrian Bridge is a signature structure crossing the corridor and connecting to the multi-use path near the baseball field. The structure is a self-tied arch with two sets of inclined arches and a longitudinally post-tension concrete deck. I don't think you'll see another one like it in North Carolina. The city of Winston-Salem and NCDOT provided a concept and prescribed aesthetic requirements for the structure. And the design build team led by HDR worked closely with the clients and other stakeholders to design and construct this innovative structure, meeting the aesthetic and functional objectives of the concept. During the early stages of design, we met regularly with the city's Creative Corridors Design Review Committee, and we incorporated aesthetic features throughout the project and really bring some vision to their vision to reality. The geometric layout of the bridge, the shape of the arches, the hanger rod arrangement, and some of the connection details were just a few of the features that we coordinated on the Green Street Bridge. So the bridge, again, it's an unbraced self-tied arch structure. It's got two sets of inclined arches and longitudinally post-tensioned concrete deck. The taller pair of inner arches are inclined outwards at 13 degrees, and these arches carry most of the load. The lower pair of arches are inclined outward at 30 degrees, and they do carry some load, but not as much as the inners. The bridge deck itself is supported by a series of stainless steel hanger rods. There's 9 hanger rods to each arch for a total of 36 hangers. Lower gusset plates are embedded in the concrete edge beam of the bridge deck, and they're used to connect the hanger rods to the bridge deck. And upper gusset plates, which are welded to the steel arch ribs, are used to connect the hanger rods up high. And the steel arch ribs are connected to concrete pilasters with anchor rods. So as you can see, there's a lot of complex geometric features with the bridge, which affects the design and carry through to fabrication and construction. We needed to make sure there's symmetry in the arch curvature along the length of the bridge. We balanced the way that the arches tilt from one side of the bridge to the other. The location of the upper gusset plate connections along the length of each of the arches and the angle of these connections was important. The location of the lower gusset plates in the concrete deck edge beam, as they're located along the length of the bridge and from side to side, and even the height of the gusset connections were important features. Deviations in any of these elements changed the angle of the hanger rod connections and changed the design loads. So those were important for us to keep a close eye on. The uniqueness of this structure required tight tolerances on several of those details. And during design, we developed a parametric bridge design model. This was beneficial in the staged analysis of the structure and proved to be an efficient way in understanding the behavior of the bridge from the different elements, especially if one of the features mentioned above needed to be adjusted. It helped us to update our design model quickly. The parametric design model gave us the basis for geometry control file, which was used to check against shop drawings. We also used this model to check against as fabricated surveys of the arches and the gusset plates after they were fit up in the field and before the pieces were welded together. At one of the stages during construction, when the bridge deck was cast and the arch ribs were positioned, the team took a point cloud survey of the field conditions of the bridge. And then we were able to overlay this model with the point cloud survey from the field to confirm that the overall bridge orientation was correct, that the positions of the arches were good, the location of the bridge deck and the edge beams were as planned, and that the hanger rod lengths, we were able to measure the actual hanger rod lengths and compare those to planned dimensions. So the Green Street Bridge, it crosses the highways in a location where there are long retaining walls on each side of the roadway. So before construction could start on the bridge, we needed to install the bridge foundations and build the retaining walls near the abutments. Temporary shoring towers were built to support the bridge deck false work. The shoring towers were located at the face of the retaining walls along the outside shoulders of the roadway and near the middle of the bridge in the roadway median area. The bridge deck false work was supported on longitudinal beams spanning between the shoring towers. There was enough vertical clearance underneath these temporary beams to allow highway traffic on the new roadway to flow without vertical clearance issues at a later stage of construction. The bridge deck was cast on false work, and then it was longitudinally post-tensioned. The steel arches were fabricated in sections and then shipped to the site. You can see in the photo that gusset plates from the hanger rods were shop welded to these arches during fabrication. The arch sections were then assembled on site, and they were surveyed, confirmed for proper alignment before they were welded together. Once the arch ribs were welded together, each of the 4 arches were lifted into place. The arch ribs were held in place by a series of temporary shoring towers and bracing. Having no highway traffic below the work area made it much easier to use temporary shoring configurations. One of the challenges was how to position and hold the arches to the correct geometry. An intricate bracing system was used to position the arches, hold them securely in place, and make subtle adjustments to the arch alignments. The bracing system allowed supports to slide along the cross beams for these subtle adjustments, and the arch ribs could be rotated within the collar connections to adjust for the proper alignment. These adjustments in the bracing system were critical for positioning the arches at the correct angle and maintaining proper alignment for the anchor bolt connection to the concrete pilasters. The concrete pilasters themselves had detailed geometry on the concrete surfaces for several different angles, and to eliminate fit-up issues on the pilasters, and the anchor bolts were cast after the arch ribs were set into place. Kind of think of it as a matched cast operation, similar to what you see in a casting yard. With the arch ribs positioned and supported and the anchor rods placed, the concrete pilasters were then poured. Once the pilasters cured, the anchor rods were tensioned, and this allowed the arches to be able to support themselves. With the arches now self-supported, temporary shoring, the temporary arch rib shoring towers could be removed in preparation for reopening the highway corridor to traffic. The arch rib cross bracing, however, stayed in place. At this stage, we performed a 3-dimensional point cloud survey of the structure. This detailed survey, it confirmed the arches were in the correct position and allowed us to recheck the distances between the gusset plate connections and confirm those hanger rod lengths. Shortly after the temporary shoring towers were removed, the Salem Parkway was open to traffic, and the bridge deck false work stayed in place. So the Salem Parkway was reopened to traffic on February 2nd, 2020. That's only 14 months since the shutdown began. So getting the Green Street Pedestrian Bridge constructed to this stage was an important part of reopening the highway. It was an incredible effort by all the team members. Although the highway was now open to traffic, there's still quite a bit of work to be done to finish the bridge. The next step was to install stainless steel hanger rods. Under nighttime closure of the highway, the hanger rods were installed and connecting the bridge deck to the steel arches. During the initial installation, the hanger rods were installed loose and they were not tensioned. You can begin to see the complexity in the different angles between the hanger rods and the gusset plate connections. For the connection between the hanger rods and the gusset plates, we used oversized forks and pins, and this allowed for greater tolerance of rotation. This helped in cases where the gusset plates may not be exactly aligned per plans. So the hanger rods included turnbuckles, which allowed the supports to be tensioned to the proper load. We were able to increase or decrease the load by adjusting the turnbuckles. The first stage was to tension the hanger rods to the inner arches. This step transferred the full weight of the structure to the pair of inner arches. At a later stage, the outer arches were tensioned, and once that stage was complete, the structure load is shared between the inner and outer arches. So to accurately measure the tension in the hanger rods, Flatiron hired WJE as a subcontractor to install strain gauges on the hanger rods and provide real-time feedback to the loads. So we work closely with a subcontractor utilizing that real-time feedback in order to adjust the loads in the hanger rods using those turnbuckles. We did this for several different stages. When we loaded the interior arches, when we loaded the outer arches, once again, when we removed the temporary cross bracing between the arches, and then finally under a final condition after the fencing and lighting elements were installed. It was a pretty tedious process. Making the adjustments to one of the hanger rods changed the tension in the other adjacent hanger rods along the structure. But we worked to balance these forces left and right of the bridge, as well as along the length of the bridge. Once the hanger rods were tensioned and the temporary cross bracing between the steel arches was removed, the temporary cross bracing for the upper arches was simply loosened and then lifted out of place. The cross bracing for the lower arches was a little more challenging because the bracing passed by the hanger rods from the inner arches. But the crews, they did a great job and they maneuvered that temporary cross bracing out successfully. So now that all the temporary bracing is removed and the structure is completely self-supporting, the temporary formwork beneath the bridge was taken down. The bridge lighting and pedestrian fences were the final elements to be installed. Here's just a couple of photos of the completed structure. There's pedestrian lighting on the bridge deck, in the bridge deck, and then along the bridge deck pathway too. And there's also decorative lighting on the arches. Pedestrian fencing is also added for safety. So you can see in the photo, the decorative lighting is added to illuminate the structures at night. And here's a pretty nice photo of the bridge at dusk. It's being lit by the aesthetic lighting, and you can see the baseball stadium there in the background. And so the next few slides have just a few before and after photos to show the enhancements along the corridor. Again, this was a project that the city and the community as a whole was really proud of. So this is an aerial view west of the Stroway Pedestrian Bridge. On the left, you see the before, on the right, you see after. So this area is just east of the Stroway Pedestrian Bridge. You can see Main Street and Church Street. This is an area where we changed the profile pretty significantly. In the old existing condition, you can see the business corridor had a large bridge that went over Liberty Street there. In the new photo, that was switched where the mainline corridor went beneath all of those structures and Liberty Street was taken up and over. So this is a photo of the very eastern limits where you can see Main Street and Church Street bridges. This is the Peters Creek Parkway before and after shot. The new Peters Creek Parkway now is a gateway entrance to the city from the west. This is closer to the center of the project, over Brookstown Avenue. There's quite a nice improvement, and you can see the city skyline there in the background. So this is a close-up of the Church Street Bridge on the eastern limits of the project. So Church Street is now a gateway entrance into the city from the east. These photos are of the strollway area. The strollway passed underneath the old existing highway. And when we reconstructed, we took the strollway up and over the corridor for that nice land bridge. And here's a quick look at the Green Street Pedestrian Bridge. You can see before was a vehicular bridge that was damaged and closed to traffic. And now it is a signature pedestrian structure. So with that, I'd like to say thank you to everybody that was involved in making the project a success. There were so many people that touched the project. And I'd like to thank the audience for letting us talk about the project a little bit today. And I think with that, maybe we can open up some questions.
Thank you very much, Rodney. It was a great presentation.
And we're going to take a look at the Green Street before and after. So again, the before photo shows that Green Street was a highway structure, and it had substandard clearances. It was struck by a vehicle at some point and damaged the exterior girder and the concrete barrier rail. And you can see the temporary fix there for the barrier rail. That bridge was decommissioned out of service until we demolished it and built back the pedestrian structure.
Rodney, this is Howard Fleming. I worked for Davenport for about 7 years. I was downtown in Winston-Salem every single day and traveling this corridor, and it's just impressive to me what has happened. I thank you for this nice presentation. I am happy that I missed the construction. But I think that one of the things that I don't think you pointed out was some of the communications you did with public with respect to the construction, whether you were going to close down the highway or leave it partially open. You polled the citizens for that, and I commend you for that.
Yes, and that's a good point. That effort was led by NCDOT to go out to the public before the project began and talked to the public about the fact that a project of this nature could last, 6 or 8 years, even if it was if traffic was maintained and had to stage construction and shift traffic. The option was to allow up to a 24-month closure and detour that traffic through the downtown area or other means. And the public did vote. And I think it was overwhelming that the public chose to allow the closure of the corridor. But again, I think it was critical that NCDOT did a very good outreach and engaged the community.
Absolutely.
So there was a question about how long was the roadway closed? The roadway was once the main line was closed to traffic, we were able to reopen the corridor in 14 months. The contract allowed up to 24, and the crews were able to reopen the corridor to highway traffic in just 14 months. And what was the advantage of complete roadway closure? I think we touched on that just a moment ago, where construction would have lasted much longer, and I think had much more of an impact to the downtown community, businesses, residents, and so on, if we had to do traffic shifts in order to rebuild the corridor. I think that we probably would have also been limited as to adjustments we could have made to the roadway profile. So having no traffic on the corridor allowed for those adjustments to take place, and we were able to minimize what impact there was to the community there.
And also,
And I'm sorry, go right ahead, please.
I was just going to remind, there's a question about the structural software that was used.
Yes, I have a roadway engineer who is asking about structural modeling. I like that. The question is, what structural software was used for modeling of the structure? So there were a couple of programs for the parametric modeling. There were softwares called Grasshopper and Rhino, and that basically allowed interface between that and the structural model. I think our guys used Larsa to do some of the structural modeling as well.
Back to
So,
the
yes, sir.
efficiency question, Rodney. I was just thinking the fact that you had accelerated this whole construction process for 14 months versus whatever it could have been. Has there been any look at the savings overall from a cost standpoint, safety, all those things, just like an advocacy for complete closure like this?
That's a great question. To my knowledge, that's not been quantified. I think that there's, from this project, I think that there's a consensus that it was definitely safer for construction crews and the traveling public. Certainly economical, but I'm not sure that there's been an exercise to quantify that to show numbers. But I am hopeful that this was a nice demonstration of what can be done and potentially used on future projects throughout the state. I see a question about the city's Creative Corridor Coalition. Yes, when we worked with the city of Winston-Salem, there is an independent Creative Corridor Coalition that helped to raise funds for aesthetic improvements on different types of projects throughout the city, and the Salem Parkway project being one of those. We did not meet directly with the Creative Corridor Coalition. However, we did meet with representatives of the coalition, and they were part of the Aesthetic Review Committee. So indirectly, yes, that's exactly right. We did do some coordination and help to incorporate some of the aesthetic features that they were interested in for the project. And I'm thinking we might have time for one or two more questions.
I have a question. So for the big change of profile in Liberty Street, when you change the big bridge to a corridor, then what was the main reason for that?
So in part, it was driven by the desire of the city to have the strollway go up and over the corridor rather than beneath. If let me try to go back. So in the before photo, you can see the strollway was underneath that large structure, very shaded, and you didn't see much of the city itself. I think the city was very interested in having the strollway go up and over the corridor so that you could see the city, the skyline, have much more of an open feel. Maybe even as an attraction to help draw more pedestrians out into the area. And it was much easier to accomplish that if the mainline profile was lowered in this region. And if not, if someone comes up with a question later on or cares to talk about their project in more detail, feel free to give me a call. I enjoy talking about the project.
Okay. Thank you very much, Rodney. It was a great presentation.
Yes, thank you all for the opportunity. I'm just happy to have been part of the project, and thanks for the opportunity to talk about it.
Okay, thank you everyone for joining us, and have a happy Thanksgiving. Bye.